notes for lesson 1.6, solving linear inequalities. So before we get started, I need to review some symbols with you. First symbol here is greater than. The second is less than. The next one, if there's a line underneath the greater than or less than symbol, it means that it could be or equal to. So this is greater than or equal to. Same with the next, less than or equal to. And the last one in this line is not equal. And again, these should be symbols that you are familiar with. Now, when we are graphing inequalities, we also need to use open and closed circles and then left and right arrows. So an open circle will be used if we are looking at less than or greater than. A closed circle will be used for less than or equal to and greater than or equal to. If we are going to the right, we will have greater than or equal to. And we're going to the left if we have less than or equal to. Again, this is just reviews of symbols that we're going to use when we are graphing inequalities. So the first example, we are looking at the difference between x is greater than 3 versus 3 is less than x. So if we think of numbers that we can plug in that are greater than 3, that would be the numbers 4, 5, 6, and so on and so forth. Now if we look at 3 is less than some number, again, we're going to have 4, 5, 6, and so on and so forth, because 3 is less than all those numbers. So another way of writing this second inequality is x is greater than 3. So we can switch the order, but if we do that, we have to flip the sign as well. And if we were to graph this, we have the 3 on the number line. It is an open circle because it is greater than, it's not or equal to, and we are going to the right. So that is the graph for x is greater than 3. For part B, if we have x is less than or equal to -2, again, we need -2 on our number line. And all I require is that you have the number on the number line. You don't need to do any additional numbers, just as long as you have the number for the solution on the number line, that's all that I care for. So -2 is on our number line. Since it is less than or equal to, it's going to be a closed circle. And less than means that we are going to the left. Now I want to look at two other inequalities. We have 2x is less than 8 versus -2x is less than 8. So we want to see what the difference is between these two inequalities. So in order to solve, we want to get the variable isolated by itself on one side of the inequality sign. So we're going to solve it just like we would an equation. So in this case, we want to get x by itself, so we divide by 2. So we have x is less than 4. It's very important that you check your solutions. So if we plug in a value for x, so a number that is less than 4, so let's try 3. If we plug in 3, 2 times 3 is 6, and 6 is less than 8. So therefore this is a true solution. So x is less than 4. If we look at the second inequality, again we want to solve by dividing a -2. So x is less than -4. So again, let's check a solution. So if we want a number that's less than -4, let's use -5. So -2 times -5 would be a positive 10. So that would be positive 10 is less than 8, which we know is not true. So this would be false. So it's very important that you check your solutions, make sure that they actually work. So it's important to remember that when we are multiplying or dividing by a negative number, we have to switch the sign. So in order to make the second equation or inequality true, when we divide by the negative, we have to switch our sign. So this should be x is greater than -4. Then if we plugged in values, then it would be correct. Let's look at a couple more examples in solving and graphing inequalities. So again, we are solving inequalities just like we would equations. So if we have 7x plus 9 is greater than or equal to 10x minus 12, the first thing we want to do is get all of our variables on one side of the inequality sign. Now whenever we have inequalities, it's easier if we have the variables on the left-hand side. It just makes our life a little bit easier. So in this case, I'm going to subtract 10x from both sides. If I subtract 10x, 7x minus 10x gives me a -3x. plus 9 is greater than or equal to negative 12. Then we need to subtract 9 from both sides. So we have negative 3x is greater than or equal to negative 21. And then lastly, again, we want to get x by itself, so we're going to divide by a negative 3. Now this is just like we just talked about. Whenever we divide by a negative, we have to flip the sign. So x is less than or equal to a positive 7. So on our graph, we're going to put 7 on a number line. Since it is less than or equal to, we're going to have a closed circle, and we are moving to the left. For number 3, again, solving and graphing. So we have 2 times the quantity n minus 4 is less than or equal to 6. Since we have parentheses, we can distribute. So we have 2n minus 8 is less than or equal to 6. We're going to add 8 to both sides. Again, we're trying to get n all by itself. 2n is less than or equal to 14. And then we divide by 2 to get n by itself. So n is less than or equal to 7. So again, we put 7 on our graph. It's less than or equal to, so it's a closed circle, and it's going to the left. Number 4, we have a word problem. So this is a real-life situation where we use inequalities. And it says the percent of households with cable TV is modeled by this equation. So this is the equation that they give us, where H is the percent of households. Where Y is the number of years since 1998. Describe the years when the percent of households with cable is less than 53.2%. So we have our equation here. H is equal to 2.3Y plus 44. We want to know when this model is less than 53.2. So we have 2.3y plus 44. And again, we want that to be less than 53.2. And then we're going to solve for y. So we subtract 44 from both sides. That leaves us with 2.3y is less than 9.2. Then we have to divide by 2.3 to isolate or get y by itself. So y is less than 4. So if we're looking at the years since 1998, it's anything less, y is less than 4. So that's going to be from 1998 to 2002. So a 4-year span. Since 1998, it can go all the way up to 4 years from then, which is 2002. We can join together 2 or more inequalities, and we call those compound inequalities. And that's 2 simple inequalities joined by an and or an or. So we're going to look at different situations for these. So for and inequalities, they can be written as 1. So for instance, it can be written as 8 is greater than x is greater than 5, or 5 is less than x is less than 8. So we can put them all together with our inequality symbols. We can also write them separately. So x is greater than 5 and x is less than 8. So numbers that would fall in that category. So x would be between 5 and 8. And we know that it would not include 5 and 8 because it's not or equal to. For or inequalities, there are 2 independent solutions. So here we have x is less than 5 or x is greater than 8. So this could be a number that is less than 5, or it could be a number that is greater than 8. So it's either one or the other. X will not satisfy both conditions. So if we look at some examples, we're going to solve these just like we solved the simple or one inequality. So we can solve and graph the inequality here. We can, with compound inequalities, if we have an and, they're written together. And if they're written together, we can go ahead and solve it all as one. If you want to break it into 2 separate inequalities, you could do that as well. But I think it's much faster to just do it all at once. So we're looking at what is in the center here. We have 2x plus 4. We want to get x all by itself. So the first thing we want to do is subtract 4. Now when we subtract 4, we have to subtract it from both sides. So on the left-hand side and the right-hand side. So that will give us negative 12 is less than 2x is less than or equal to 6. Again, we're still trying to get x by itself. So next we're going to divide by 2. Again, we have to divide everything by 2. So this is negative 6 is less than x is less than or equal to 3. Now another way of writing this would be x is less than or equal to 3 and x is greater than negative 6. So if we graph this on our number line, we need negative 6 and we need 3. Negative 6 we're going to have an open circle because it's less than. And 3 we're going to have a closed circle because it's or equal to. And again, we want less than 3, but we also want greater than negative 6. So it's going to be this area in between the two numbers. So between negative 6 and 3. The next one we are solving is an OR problem. So we have two different inequalities to solve. So the first one we have 6x plus 9 is less than 3. Again, just solve it just like an equation. So we're going to subtract 9 from both sides. So 6x is less than negative 6. Then we divide by 6. So x is less than negative 1. Then we're going to solve the other inequality. So we're going to add 8 to both sides. That gives us 3x is greater than 21. Divide by 3 to get x alone, and x is greater than 7. Remember, this is OR. So x is less than negative 1, or x is greater than 7. So we need negative 1 and 7 on a number line. They are both open circles because they are not or equal to. From negative 1 we are less than, so we're going to go to the left. From 7 we are greater than, so we're going to go to the right. So OR functions or OR graphs should be going in opposite directions because it's one or the other solution. We have 2 more examples to look at for solving and graphing inequalities. Again, we are solving just like an equation. So if we look at our first inequality, we have negative 2 is less than or equal to x minus 7, or 11 is greater than or equal to x minus 7. So our first step is going to be to add 7 to both sides. So we end up with 5 is less than or equal to x. Remember, we can change the order of our numbers and our variables. However, we need to switch the sign. So this is the same as x is greater than or equal to 5. If we solve the other inequality, again, we're going to add 7 to both sides. We get 18 is greater than or equal to x. Again, we can switch the order, so x is less than or equal to 18. Remember, this is an OR, so either one or the other has to be true. So when we graph, we need 5 and 18. They are going to be closed circles because they are or equal to. So 5 we are going to the right, 18 we are going to the left. Now again, this is an OR situation, so we're going to continue our lines all the way across. Notice we've filled up the whole number line, so this tells us that all real numbers will work as a solution. So because it has to be one or the other, any number would work for these inequalities. And again with number 4, solving just like we would before. So the first inequality, we are adding 1 to both sides, so x is less than or equal to 6. The second inequality, we are subtracting 3 from both sides, so x is greater than or equal to 7. Graphing them on the number line, we have 6 and 7, again both closed circles because they're or equal to. 7 we are going to the right, 6 we are going to the left. Now we need to go back and look, we have an AND. So that means that our solution must satisfy both inequalities. So if we look at our solution, there are no numbers that are overlapping or no numbers that will satisfy both inequalities. So in this case, it is actually no solutions. So it's important that we see what combination of inequalities we have and that we double check our solutions to make sure that they make sense with the situation.